So this is the sixth session on Newton's laws of motion. This is a continuation of the fifth video. Okay. So in this I'll take up discussion on numerical problems on Newton's second law of motion. Okay. So in case you have any doubt, you go to the previous video. You'll get all the results. Okay. So in this problem, I just write down the working formula. For application on Newton's second law to a point as seen from inertial frame, say ground frame. Okay, so that working formula is this: f dash minus f double dash ma dot n hat. This is the working formula for Newton's second law applied to a point or a translating body along some direction along which unit vector is n hat. F dash is the sum of components of all the real forces on the particle along n hat which make acute angle with n hat. And f double dash is the sum of magnitudes of components of all the real forces on particle along n hat which make obtuse angle with n hat. Okay, fine. A dot n hat is just the component of acceleration of point along n hat. Okay. In case we want to apply Newton's second law along x-axis, then this equation becomes fx dash minus fx double dash n times ax. Meaning of fx and fx double dash is same as was here. In this only we take x component. Okay. Similarly, if we apply Newton's second law along y direction, fy dash plus this becomes n times ay. And if we apply Newton's second law along z direction, fz minus dash is just equal to m times az. Okay. Fine. Alright. So this is the working formula just stated here. Okay. So now I'll take up some problems. Okay. Fine. So first question I'll take up. First question. See, first question with direct illustration of these formulas. Okay. So problem is this: a particle P of mass equal to 2 kg is at origin of the coordinate system. Origin of the coordinate system, and several real forces act on it as shown. Several real forces act on it as shown. From this diagram, find the magnitude of acceleration A of particle with respect to inertial frame. So if nothing is specified, then instead of inertial frame we take the ground frame. Okay, fine. Instead of inertial frame we take what? Ground frame. Alright. So I draw the diagram here. See, this is the positive x-axis, this is the positive y-axis. This is the origin of coordinate system. Particle is situated here. One force acts in this way, 10 Newton along positive x-axis. 14 Newton acts say along 30 degree direction. One more force acts say 20 root 2 Newton along 45 degree angle. Okay. One more force I show here, 6 Newton say along 60 degree. Okay. And then I show here some 8 Newton force say along 30 degree. Okay. This is the situation. All the forces on the point act in xy plane. There is no force along z axis. Okay, fine. So now we have to find the magnitude of acceleration A of point. We have to find the magnitude of acceleration A of the point with respect to ground frame at the given instant. Inertial frame here, ground frame, it is usually taken to be. So let A be the magnitude of acceleration. Question is, from where do we start? How do you start to solve the problem? A will be equal to root under ax square plus ay square plus az square. Now A is the magnitude of acceleration, that is from the theory of vector, it is this much. So to find A, we must know ax, ay and az. Okay. First what we do, we determine ax. To determine ax, we apply this equation. So to find Ax, we write Fx dash minus Fx double dash is equals to mass times Ax. Now what is Fx dash? Fx dash is the sum of x component of real forces on the particle which make acute angle with positive x-axis. So what is that is Fx dash. So now which forces on the particle make acute angle with positive x-axis? This 10 Newton. It is along 0 degree x-axis to 0 degree. So Fx dash becomes 10. This force 14 Newton. This also makes an acute angle 30 degree with positive x-axis. Fx dash becomes 14 cos 30 degree. 14 root 3 by 2. Now this force 20 root 2. This also makes acute angle 45 degree with positive x-axis. So we add this also. Thus 20 root 2 cos 45 degree. Cos 45 degree becomes 1 by root 2. And remaining forces make obtuse angle with positive x-axis. So these three terms add up to Fx dash. This is Fx dash minus Fx double dash. Now what is Fx double dash? Fx double dash is a sum of magnitudes of x components of all the real forces on particle which make obtuse angle with positive x-axis. Now see, only these two forces make obtuse angle with positive x-axis. So we find the magnitude of x component of these two forces and add them. That will be Fx double dash. So here what we do, 6 magnitude of x component of the 6 Newton force is 6 cos 60 degree. So 6 cos 60 degree becomes 6 by 2 plus x magnitude of x component of 8 Newton force. This also makes obtuse angle 150 degree with positive x-axis. So magnitude of x component of 8 Newton force is 8 cos 30 degree. 8 root 3 by 2. Okay. That is equals to mass times Ax. M is the mass 2 kg. Okay. So when you solve this, we get Ax from here. So I'll rub this one. Okay. Fine. So 14 root 3 by 2 becomes 7 root 3. So 10 plus 7 root 3 plus 20 is equals to 2 times Ax. Minus 6 by 2 becomes 3. 8 root 3 by 2 becomes 4 root 3. That is equals to 2 times Ax. So 2 times Ax becomes 10 minus 3 becomes 7. 7 plus 20. 10 minus 3 7 plus 20. 7 root 3 minus 4 root 3. 3 root 3. So Ax becomes 27 plus 3 root 3 by 2 meter per second square. One answer has been obtained. Now we have to determine next Ay. Ay has to be found out. For that, what do? We apply Newton's second law to this point along positive y direction. This formula has to be used. Then we get Fy double dash minus Fy double dash is equals to m times Ay. Now what is Fy dash? Fy dash is the sum of y components of all the real forces on particle which make acute angle with positive y-axis. So if this 10 Newton is right angle, so it makes right angle. It has no component in a y direction. Only these two forces make obtuse angle with positive y-axis. So Fy dash becomes 6. This is 30. So this is 60 degree. Fy dash becomes 14 cos 60 degree. 14 by 2 plus 6. Also this 6 Newton makes 30 degree. 60 is 30 with positive y-axis. So Fy dash we add 6 cos 30 degree. So sum of these two terms is Fy dash. Now we have to find Fy double dash. Fy double dash is the sum of magnitudes of y components of all the forces, real forces in particle which make obtuse angle with positive y-axis. Only these two forces in particle make obtuse angle with positive y-axis. This is 120 degree, this is 135 degree. So if we find the magnitude of y component of these two forces and add them, we get Fy double dash. So Fy double dash becomes, this is 30. So this is this angle is 60 degree. This 45, this is also 45 degree. So Fy double dash becomes magnitude of y component of 8 Newton force, 8 cos 60 degree, 8 by 2 and 20 root 2 cos 45 degree. 20 root 2 by root 2, that is equals to 2 times ay. I hope it is clear. Fine. So from this we simplify, we get the value of ay. This one I rub it, okay? So if I simplify it, how this becomes how much? 7 3 root 3 minus 4 minus 20 2ay. So this becomes 2ay is equal to 3 root 3. 24 minus 7 becomes how much? 16? No, 17. How much will become? 24 minus 17, it becomes 17. Okay, fine. So 2ay becomes 3 root 3 minus 17. Some 3, okay, yes, minus 17. So ay becomes 3 root 3 minus 17 by 2 meter per second square. Okay, this becomes ay. Ax also we have already found out. Ax is where? Ax is where? Ax, okay, Ax is this, ay is this. And finally we have to find Az. Now all the forces on particle are in xy plane. There is no force along z axis. So since Fz is 0, so Az also becomes what? 0. Okay. So now what I do, I substitute this Ay and Ax and Az in this formula. Then I get the magnitude of acceleration of point A. Alright. So I rub this one. So magnitude of A becomes root under Ax square. How much is Ax? 27 plus 3 root 3 by 2 whole square plus Ay square. 3 root 3 minus 17 by 2 whole square. Az is 0 square meter per second square. This is therefore the required answer. Okay. So if you leave it or you simplify, it doesn't matter. If you get the expression, it's all right, completed. Okay. So this is the magnitude of acceleration of point A. This is just equal to this much meter per second square. This is therefore the required answer. Okay. Fine. Now rub this one. Okay. Now I'll take up another question, question 2. Okay. Another example is this. A particle P of mass m barabar 2 kg. I'll write down the question. Of mass m 2 kg acts on a particle P whose coordinates at time t are given as t, t cube, t square and t power 4. Okay. Question is, find the magnitude of, find the net force. Find the net force on the particle in I hat, j hat, k hat notation at time t, and also the magnitude of the net force on the particle at t is equal to 2 seconds. Okay, this is therefore the required question. Okay, fine. So now what I do, I rub this one. Okay, See, the problem is this. So here, see, we have just to find out the magnitude of net force. So here there is no meaning of writing F dash, F double dash, etc. We just write down the Newton's second law as usual. What you write it? M into A. F is the net force on particle. Okay. So here you don't have to write F dash, F double dash, etc. Simply net force equals to mass times acceleration. Okay. Now M is known how much? 2 kg. Now we have to know the vector A. Vector A in Cartesian form will be written as Ax I hat plus Ay j hat Az k hat. Okay. This is the vector expression vector A. Alright. Now to know A we have to know Ax, Ay, Az. Now Ax we know is how much? dVx by dt. That we know is how much? d by dt of dx by dt. This becomes d by dt of x coordinate becomes how much? T cube. This becomes d by dt of t cube becomes what? 3t square. d by dt of 3t square becomes how much? 60. Ax we have found out. Now we have to know vector A, we have to know Ay. Ay is similarly written as d by dt of, instead of x we put y. d by dt of y. Now y is how much? Y is t square. This becomes d by dt of what? T square. This becomes d by dt of t square becomes 2t. And when this is differentiated we get 2. So Ay also we have obtained. Now to know vector A we must know Az. Now Az again will be written as dVz by dt. That will be written as d by dt of dz by dt. That will be written as d by dt of what is z coordinate at time t power 4. Okay. And when this is simplified, this becomes d by dt of t power 4 becomes 4t cube. So d by dt of 4t cube. So this becomes 12t square. Okay. All the three components have been fully determined. Okay. Fine. Alright. So mass is 2 kg. Okay. Ax is this much, Ay is this much, Az is this much. Okay. Okay. I rub this one. Fine. So net force on the particle in vector notation becomes F equal to NA. N is 2. Vector A I write is this. Ax I write this one 60 I hat. Ay becomes how much? 2. So 2 j hat. And Az becomes what? 12t square. 12t square, no? 4t cube. T power 4. 4t cube 12t square. Okay. Plus 12t square into what? K hat. Alright. This is what is force F becomes. So this is equal to 12t I hat plus 4j hat 24t square k hat. Okay. This is therefore the answer to the first part of the question. In second part it has been asked to find the magnitude of net force on particle at t barabar 2 seconds. Now magnitude of force F at arbitrary instant is simply from the vector theory fx square plus fy square plus fz square. So this becomes root under fx becomes 12t. This is the x component of force F. 12t whole square. Fy becomes 4, so 4 square. Fz becomes 24t square whole square. So this is the magnitude of resultant force on the particle at arbitrary instant t. But we have been asked to find out the magnitude of net force on particle at t is equal to 2 seconds. So at t is equal to 2 seconds, magnitude of net force on particle becomes 12 into 2, 24 square plus 4 square, and t square becomes 4. 24 into 4 becomes 96. 96 whole square newtons. This is therefore the required answer. You leave it as it is, there is no problem. Okay, no need of simplifying it. If you get this much, you already have obtained the answer. Fine. And they close this also. This option is finished. Okay, now I'll take up another question. Okay. Now I take up the third problem on this video. Third question. Third question is this: a particle P of mass m moves in xy plane such that at time t its coordinates are given as x equal to a cos omega t and y is equal to b sin omega t. Here a, b and omega, they are positive constants. Question is, find the net force F on the particle at arbitrary instant t. At arbitrary instant t in I hat and j hat notation. Also express the result in terms of position vector r of the point with respect to origin. All right, fine. This is the question. So how do you start to solve it now? Again, see, first of all, again we have to find the net force. So we don't have to write f dash and f double dash separately. We simply write on the vector form of Newton's second law, net force equals to mass times acceleration. This F is the net force on particle which we have to determine. Okay. So this is the net force F on the particle which we have to what? Determine. Alright, fine. Now to know F, we must know A. M is given, we must know vector A. Now A is the acceleration vector of particle, which is in IJK notation is written as AX I hat plus AY J hat plus AZ K hat. But see, point moves in xy plane always, so it has no movement along z axis. So there is no motion along z axis at all. So AZ becomes 0. So this term drops out. Now we are left only with AX and AY. Now what is AX? AX is the x component of acceleration of point P, that will be written as, from the kinematical theory, d by dt of x. Okay. Now x is what? A cos omega t. Instead of x I write this A cos omega t. So this becomes d by dt of A cos omega t. So this becomes d by dt of this becomes minus A omega sin omega t. Now minus A omega is constant, it comes outside. D by dt of sin omega t. Now this becomes omega cos omega t. So this becomes minus omega square A cos omega t. Okay. So this is the x component of acceleration of particle at arbitrary instant t. Now we have to determine Ay. Ay is the y component of acceleration A of the particle. Okay. So Ay will be written as what? D by dt of dy by dt. Okay. So this becomes d by dt of v sin omega t. Okay, fine, all right. Now I rub this one, okay. This becomes how much? Ay becomes d by dt of b sin omega t becomes b omega cos omega t. So this becomes b omega cos omega t. We derivate the b omega as constant, comes outside. Minus omega square b sin omega t. So we obtained ax and ay both. Now we substitute ax and ay in this. This term goes away as I mentioned just now. The expression vector a of point at time t becomes minus omega square a cos omega t into I hat minus omega square b into sin omega t j hat. Okay. Now to find the net force on particle, we multiply this by a by m. So net force on particle at time t becomes mass times minus omega square a cos omega t I hat omega square b sin omega t j hat. Okay. This is the first answer to first part of the question. In which it was asked to find the vector form of f in IJK notation at arbitrary instant t. The second part of the question says that you have to express the vector f in terms of instantaneous position vector r of the particle from origin at time t. So for second part, what we do, we take omega minus omega square common. So this becomes minus m omega square a cos omega t I hat plus b sin omega t j hat. This becomes minus m omega square a cos omega t is given to the x coordinate of point at time t, and v sin omega t is given to the y coordinate of particle p at time t. Now this minus m omega square, we know from the kinematics, particle kinematics theory, this quantity is nothing but the position vector of point p with respect to origin at time t. So this becomes minus m omega square vector r. Okay. So net force on particle becomes what? Net force on particle becomes minus m omega square vector r. Okay. So this is the answer to second part of the third question. Okay, fine. This also solved. I'll take up one more question on this in this video. Okay. I love this one. Now I take up one more question. See, this is the fourth example in this video. Fourth example is this. A particle P of mass m is initially at rest and is acted upon by a time dependent one dimensional force F, which is given as F is equal to lambda t square into t minus small t. Here lambda is a positive constant and capital T is the duration for which the force acts. Duration for which the force acts. Okay. Question is, find the speed, find the distance covered by the particle starting from initial instant till the instant action of force discontinues. Of continues. Okay, this is the required question. Okay, fine. I solve the question. Okay. Now this force C, at time small t 0, this force is 0, and when t becomes capital T, again it becomes 0. And for intermediate instance C, for t lying between capital T to 0, this force has a positive magnitude. F is positive. This means during the entire duration for which the force acts, the direction of the force is same. It doesn't reverse in direction at any instant. Okay. So we apply Newton's second law to this point along this straight line. So in this we apply Newton's second law to point along the line of its motion. Okay. And in this case, since force is in same direction always, acceleration also in same direction. Direction of acceleration doesn't change. So you simply write down net force on the particle is equals to mass times acceleration. Okay. Now net force is this given to this is F dash. There is no F double dash. Is it clear what I am saying? Suppose this is the line of force is directed along this direction, say. Okay. Now in 0 to, as I have stated just now, for small t line in 0 to capital T, force is 0. So direction of force is fixed along the same direction. So here we are applying Newton's second law to this point along the direction of its net force. That is the direction of its net acceleration. So we write the force here. So F dash minus F double dash is equals to ma dot n hat. F dash is just the magnitude of sum of magnitudes of all the real forces on point which act along this direction, which is simply F. And F double dash is 0. So F double dash is the sum of components of sum of magnitudes of the components of those forces in real. So F double dash, I'll repeat, F double dash is just the sum of magnitudes of the components of real forces on particle along n hat which make obtuse angle with n hat. There is no such force which makes obtuse angle with n hat. So F double dash becomes 0. And m a dot n hat simply becomes a into 1 into cos 0 degree, that becomes a. Now force is a time dependent force, so acceleration is not constant, it varies with time, but direction is fixed. So we say m times dv by dt for a point moving on straight line. Acceleration a will return as dv by dt. That is just equal to f. F is how much? Lambda t square into t minus t. Okay, fine. I love this one. So what we do first, we determine the speed of point at some arbitrary instant small t, and then write v as ds by dt and then integrate again. Then we get the distance covered by point in the required time interval. Okay. So I write this as m dv equal to, I shift dt right side, that becomes lambda into tt square minus t cube into dt. Now I integrate this equation on both sides. Tt square minus t cube into dt, and limit of small t will be from 0 to small t. When time is 0, point was at rest, so v is 0. Upper limit when t is small t, speed is v, say. Now m is constant, m goes outside the integral. M integral dv 0 to v. Lambda is constant, comes outside. 0 to v, this becomes tt square minus t cube into dt. So this becomes mv equal to lambda times. Now this we integrate, this t is constant, t square becomes t cube by 3 on integration and inserting limits. This becomes t power 4 by 4. Okay, so v becomes lambda by m tt cube by 3 minus t power 4 by 4. This is the speed of the particle at arbitrary instant t. See, one thing I'd like to say, we have been asked to find the distance covered. Okay. See, when we integrate velocity with respect to time, we get displacement. And when we integrate speed with respect to time, we get distance. But see, for a point moving along straight line, if in a given time interval its motion direction doesn't reverse, then distance and displacement both are numerically equal. So this is the case in this problem, okay? Throughout the course of its motion is moving along a straight line without reversing its direction. So distance and displacement are numerically equal. So here if we integrate velocity also with respect to time, we get the distance covered, okay? And sometimes it happens that, in majority of the time it happens that distance and displacement are numerically equal. This is the case when the motion direction of the point doesn't reverse in straight line motion. But in case motion direction reverses in that interval of interest, then they are not the same. Distance is not same as displacement numerically, okay? But in this case they are same. Now this v is velocity, it is also the speed, because magnitude of velocity is the speed. So this is also write as speed, ds by dt. Now I shift dt that side, so ds becomes what? Lambda by m dt cube by 3 minus t4 by 4 into what? Dt. Okay, fine. This one are a bit, okay? Now what I do, I integrate this equation on both sides. 0 to capital T. See, we have been asked to find the distance covered in time 0 to capital T. So capital T, because force distance continues after this time. And when initially 0, S is 0. When T is capital T, S is S. Integral ds 0 to S becomes S. Lambda by m is constant. This becomes dt cube by 3. T by 3. And t cube dt becomes capital T power 4 by 4. On is integrating and inserting limits. This when integrated becomes t power 5 by 20. So distance covered becomes lambda by m t power 5 by 12 minus t power 5 by 20. So this becomes lambda by m 60, t power 5 becomes common, 5 minus 3. Okay, on simplifying it, this becomes how much? 2 by 61 by 30. Lambda t power 5 by 30 m. This is therefore the required answer. I hope it is clear. Fine. So distance covered becomes lambda t power 5 by 30 m. Is the distance moved by the point in the duration in which the force acts on the point, one direction force. Fine. So this was the second, sixth video on Newton's laws of motion. In successive videos, I'll take up some more integration based problems. Okay, fine. I'll take up some more integration based questions. I'll take up. Okay. This I close it here. Fine. If you go through it properly, you'll be able to understand everything. And you take a problem from any source, I'm sure you'll be able to solve most of them. In case you have any difficulty, you write the difficulty in the comment box. I'll rectify it. Okay. Fine. All right.